Problem 4. The figure above shows a graph of f prime, the derivative of a twice differentiable function f, on the closed interval from 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, x equals 3, and x equals 5. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. All right, for part A it says find all values of x on the open interval from 0 to 8 for which the function f has a local minimum. Justify your answer. Okay, local means the same thing as relative. So if I'm looking for a relative minimum, I would like an f prime chart. Right? And if I'm drawing an f prime chart, this is a picture of f prime. So since I'm going from f prime to an f prime chart, I will be looking at above and below the x-axis. So when I do that, this graph is above the x-axis till I get to 1, and then it stays above till I get to 4, and then it dips below till I get to 6, and then it goes above after that till I get to 8. So it stops at 8 and it stops at 0. Right, so if I want to know where there is a relative minimum would occur when the f prime changes from negative to positive, so that's going to be at x equals 6. So there is a local minimum at x equals 6, and that is because f prime changes from negative to positive. And that was worth just 1 point. Great. All right, part B. Determine the absolute minimum value of f on the closed interval 0 to 8 and justify your answers. Okay, the difference between absolute, we need to find critical numbers, and then we also need to find the actual values of f at the critical numbers and the endpoint. So if we look back at part A, we already found that our critical numbers were on our chart. They were 1, 4, and 6. So we actually are going to find f at 1, at 4, at 6, and then we also had to find it at the endpoints at 0 and at 8. So we've got lots of work cut out for us here. Okay, and we know nothing about f, but we do know something about f prime, so I do know that I'm going to have to end up taking the integral of f prime. That will give me f. And I do also know that they told me what f of 8 is, so I'm always going to go to 8, and then I'm going to use each of these x values from my critical numbers and endpoints to do the rest of the problem. So this first one, to get f of 1, I'm not going to put an equal sign quite yet because it's not going to equal that yet. Okay, to get f1, I'm going to find the integral from 1 to 8 of f prime. And when I do that, the integral of f prime, when I take the integral, will just give me f, and I'll have to evaluate it at 8 and then subtract what I get at 1. Okay, now to get the integral from 1 to 8 of f prime, I just look at the area under the curve from 1 to 8. So if I'm looking at the area under the curve from 1 to 8, it would be from here all the way up to 8. So this is going to be 6 minus 3, which is 3, plus 7, which is 10. So this is going to be 10 equals, I already know that f of 8 is equal to 4 because they told me that, so it's going to be 4 minus f of 1. And now I'll be solving for f of 1, so I'm going to subtract 4 from each side. So I'll get 6 equals negative f of 1, which means f of 1 is equal to negative 6. All right, we're going to do that same thing for every single one of these. This next one, I'll go from 4 to 8, and that will give me f of 8 minus f of 4. Then to find the area under the f prime curve from 4 to 8, 4 to 8 will just be from here to here. It's going to be negative 3 plus 7, which is 4. And f of 8 we already know is 4 minus f of 4. If I subtract 4 from both sides, we'll just get 0. So f of 4 will equal 0. All right, my next one, f of 6, we'll be taking the integral from 6 to 8 of f prime. When I do that, I'll get f of 8 minus f of 6, and to get the integral of f prime from 6 to 8, we'll just find the area under the curve from 6 to 8, and that does tell us that is 7, so we'll get 7 equals f of 8 again is 4 minus f of 6. If I subtract 4 from both sides, I'm going to get 3 equals negative f of 4, which means that f of 4 equals negative 3. All right, next one, getting 0. If I go 0 to 8 f prime, that is going to give me f of 8 minus f of 0. And then the integral under the area under the curve from 0 to 8, so going all the way from 0 to 8, I'll have 2 plus 6, which is 8, minus 3, which is 5, plus 7, which is 12. So I'll get 12 equals, f of 8 is still 4, minus f of 0. If I subtract 4 from both sides, I'm going to get 8 equals negative f of 0, which means that f of 0 is equal to negative 8. And then my last thing, f of 8, will be the integral from 8 to 8 of f prime, and without even doing any work, if you're just going from 8 to 8, you will get 0 as an answer. So now we are looking for the absolute minimum, so I'm just going to look at which one of these, if I look at all these answers, which one of these gave me the smallest value, and the smallest value I got was negative 8. So the absolute minimum was negative 8, and I did justify my answer. All this work down there was definitely justified my answer. Great, part C. On what open intervals contained between 0 and 8 is the graph of f both concave down and increasing? Okay, if f is concave down, we know that f double prime will be negative, and if the function is increasing, f prime will be positive. So I'm going to go back to my f prime chart to figure out where I'm going to be positive. So I'm just recreating my f prime chart here. 4, 6, I'll get plus, plus, minus, plus. Okay, and then to do f double prime, to get from f prime to f double prime, we'll be looking at the slopes of the graph. So if I look at the slopes of the graph, the slopes are negative till I get to 1, and then they are positive till I get up to 3, and then they're negative till I get to 5, and then they looks like they're positive the whole time after that. So that's what my f double prime chart will look like. So I need to find out where is my f double prime negative and my f prime is positive. So it looks to me like from 0 to 1 for sure right here, we've got both positive and negative. So that will be one spot. So it'll be 0 to 1. And then is there another spot where my f double prime is negative and my f prime is positive? So I'm going to say right here, it starts at 3 because f prime is positive at 3, and then I'm going to have to stop it at 4. So the other spot is 3 to 4. So, and I will say this is because f prime is positive and f double prime is negative. So there we go. That part would have been worth 2 points, 1 for the answer of 0 to 1 and 3 to 4, and 1 point for your justification. Okay, and the last part, the function g is defined by g of x is equal to f of x cubed. If f of 3 equals negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. So we just need to find the slope, and when I see the word slope, I know I need to find the derivative. So if we have got g of x is equal to, in parentheses, f of x cubed, I know since I have parentheses, I get to use the chain rule. So I'm actually going to do u for this one, make it u cubed. And so I know the derivative will equal 3u squared times du. So when I go to find this derivative, 3u squared, u again was f of x. I guess I could have clarified that this was u, squared, and then times derivative, the derivative of f of x will be f prime of x, and we would like to find the slope of the tangent at 3. So I'm going to go wherever I have an x and put 3 in. So I'll get 3 f of 3 squared times f prime of 3. Okay, so I'm going to have 3 times f of 3, they nicely told me was negative 5 halves. So it's going to be times negative 5 halves squared times f prime of 3. Well, if this is a picture of f prime, I can just go to 3 and look at what my value is, which is 4. So now just simplifying this a little bit more, we'll have 3 times 25 fourths times 4. My 4's are going to cancel, so 3 times 25 is 75. So that will be the slope of the tangent at x equals 3. That was worth 3 points. We got 2 points for properly taking the derivative of g, and then we got 1 point for getting our right answer. So there we go once again.